Hey everyone, welcome back to another Infernomon devlog. I know it's been a while since I made my last video. That's because I took some much needed time off from work and also from game dev, and I went on a few vacations. But now that I'm out of vacation money and exhausted all of my paid time off from work, it's time to jump back into game dev, and I'm going to be going hard from now until Christmas. But in between vacations, I did manage to get in a little bit of game dev over the past couple months. I was able to leverage ChatGPT to gain some inspiration for generating ideas for the first dungeon map in my game, as well as build some of the actual assets in my game. After ChatGPT helped me build some assets, I was able to import those assets into GameMaker and start updating my dungeon map generation algorithm. And the updates I made to my algorithm are going to make it more like a Survivor, where there's one big room and there's monsters coming in from a bunch of different areas within the map. And that's going to be changing from what I had before, where there was multiple rooms in the dungeon, you navigate from room to room. So without further ado, let's jump in and take a look at everything that's changed. So the art in my game had been in there for a long time and was very much in need of an update, especially now that I've made it so each dungeon in my game is going to have 2 elemental typings instead of just 1. So I originally started building the first dungeon in game to be just only ground elemental typing. There's only about 6 or so different enemies in that dungeon and didn't have much variety. So I decided the best thing to do was to have each dungeon have 2 elemental typings. So that would make it so each dungeon would have roughly 12 different types of enemies in the dungeon. So before, when there was only 6 or so different enemies in each dungeon, that made it so that each dungeon was pretty cookie cutter and you'd use the same lineup to battle each dungeon. But now that there's 2 elemental typings for each dungeon, it's going to involve a lot more strategy for your team building, and there's going to be a lot of different combinations that you can make for your teams. So the way I decided which 2 elemental types would be in each dungeon in my game, I started looking at all the Infernomon in my game and looked at things like if they're ranged attackers or versus melee attackers, if they do physical damage versus special damage, if they're tanks versus assassins, and so forth. So I tried to make it so each dungeon had a decent variety of all those different kinds of roles in each dungeon. So ultimately, this is kind of what I've settled on. I have 4 different dungeons plus a 5th final boss dungeon that I haven't really planned out yet. But for the first 4 dungeons, I'll just kind of scroll through this Word document here. I actually had ChatGPT kind of help me build the themes for each of the dungeons and generate a couple images. So the first dungeon is going to be electric and ground themed, and it's going to be called Thunderstrike Desert Ruins. Feel free to pause the video if you want to read these theme concepts. And then the second dungeon is going to be Swamp of Mystic Shadows. This is where I'm going to be combining arcane and water elemental typings. And then the third dungeon is going to be called Blazing Windstorm Peaks. So you got this kind of like fiery volcano windstorm theme going on. And then the last dungeon in my game is going to be called Blighted Toxic Grove, and I'm going to be combining Toxic and Blight Infernomon. So like I said, I used ChatGPT to kind of come up with these themes, and I fed it in the Infernomon that would be in each dungeon. So now that I had a good idea around what the themes of each of my dungeons would be, it was time to jump in and start actually building the art. So what I did was I once again went back to ChatGPT, and I told it to try generating a tile set based off of the original image that it generated. And this is kind of the first thing that it came up with. It didn't exactly work as far as a tile set goes, and it was a little bit off. So I'm like, well, can you just kind of give me an example of what a map would look like with these tile designs? And then it generated this image, which I thought was actually a pretty good 2D game image. So I really like this here. And so from here, I tried a bunch of different times to get it to generate tile sets, and sometimes it would do a few good things, and then sometimes it would do a few weird things, but it never really came up with like an entire set of tile sets that would actually work. So after a few failed attempts of ChatGPT trying to generate a tile set for this image, I ultimately decided that I would just start building at least the wall tile set myself, and then maybe I would have it ChatGPT build the actual assets in the map. So take a break there and then jump back in once I have the wall tile set generated. So over the next few mornings, I started building the wall tiles for the first dungeon in my game. The first thing I did was I actually took some screenshots from this dungeon image here of just the walls, and then I went over to paint.net and I pasted all the different screenshots in and adjusted it to fit on this kind of grid system that I have going. And so these grid squares are the same size as the grid squares in my game. They're 90 pixels by 90 pixels. So I kind of just stretched them to where I needed to, to get an example image that I could use to kind of reference when I was building my own wall. So this is what I ended up building. I like having this little grid layer here in paint.net that I can draw on top of. So if I toggle this on and off, you can see the grid show up and disappear. And I could kind of use this as a reference when I'm building the tiles. If anybody watching this is familiar with building tile sets, they're probably cringing right now because there's probably better ways to do this, or they could do this a lot quicker, but this took me a long time to actually do and try to figure out how to build a variety of different tiles that would actually work in my game. But basically what I started doing to get the colors right is that I would come over here, get this little color picker here and pick a color from the bricks on this image, and then I would kind of draw the shape of the walls on this image and paste the color in, and I kind of followed that pattern for all the different blocks on the walls. So when I was in here, I made the walls 3 tiles high. In my old map, they're only 1 tile high, so this is gonna force me to tweak the algorithm here in a bit. And then I also made it so the brick lines on some of the different tiles are spaced out somewhat differently, so that when my algorithm is placing the bricks, it's not always going to place the brick line in the exact middle, so it's going to have a slightly less than perfect layout, which is going to kind of make it look a little bit more realistic. Because if you go back to this image, for example, some of these bricks are small, some are big. And so yeah, I thought that would work better if I kind of had a little bit of random spacing within the bricks. So after generating this wall tile set, I ended up taking all these little squares and turning them into their own images and then loading them into GameMaker. So if I go into GameMaker and then go to the walls section here, all of these walls are from the wall tiles that I just generated and then uploaded. So there ends up being, I don't know, maybe 20 something or 30 something different walls that I ultimately ended up building. But now I'll jump into the actual code and show you the changes that I made to get this wall tile set to work. So one of the first things I do in my dungeon algorithm is I create all the border floors in my game. I won't go into this function here, but basically this kind of goes in a zigzag pattern all the way around the outsides of the map, placing floor tiles. And then after that, I fill in all the floor tiles in the middle of the map. If you want to know how I did this, you can go back and watch one of my older videos. So basically at this point, before I start creating the walls, I have all the floor tiles in my game spaced out somewhat randomly. And then I call this create walls function here. So all this function does here, this create walls, is it goes around the outsides of the map, finds all the position of the floor tiles and makes sure that it places the dungeon walls on the outsides of the floor tiles. And so once I've placed all the wall tiles here, I haven't set the sprites on any of the wall tiles. So then after that, I call this set dungeon wall sprite orientation. And so then if I go into this function, this goes and looks at all the different angles that the floor tiles are spaced around the wall. And then it gives it each wall this wall type here. So for example, if it was on the very bottom middle of a floor tile, then let's give this horizontal type. So it knows it's going to have to place, if I go over to paint.net, it's going to have to place one of these horizontal floor tiles here. So in my wall object on the step event, because I had this initialized variable here, so essentially after it goes through this chunk of code where I set the sprites for the wall, it'll set this initialized to true and it won't set the sprites ever again. But basically, based on the wall type that I set before, it's going to determine what sprites to use for that wall. And I do this all starting from the bottom layer of the wall and moving up. I first determine based off the type whether it's going to be placing, like horizontal wall, a corner wall, or a vertical wall. And then I have some logic here for checking if the wall has a brick line. And so if the wall does have a brick line, it's going to make it so the wall layer above it is not going to have a brick line. And then the very top layer is going to have a brick line. And then if I go into the draw event here, this is the actual logic for drawing each different layer of the wall. So I jump into my game, there was one final piece of logic that I added to the walls. And that is if you go behind a wall, it'll fade to being slightly transparent. So those are all the updates I made to the walls of my game. Now I will go into reviewing what I did to generate the obstacles. So after finishing the walls, I spent the next few days really trying to figure out how to use ChatGPT to generate the art that I could use for the map assets. I previously used placeholder art that I drew by hand and it looked terrible. So my goal now is to get the art in my game at least to a standard I'm okay with for releasing the first playtest version of my game. I didn't know how much time I actually wanted to spend improving the art just to get it ready for playtesting, but I didn't want to release something that looked completely terrible. So I first told ChatGPT to build art that would fit in well with the walls that I generated. So I fed it this wall image here. It did a pretty decent job the first time at generating this handful of images here. So I took these images and loaded them into my game. And if you look closely, these images are a little bit grainy and had too much texture. So I ultimately decided that, we needed to make that a little more flat, I guess. So after that, I uploaded an image that I liked the art in, that I wanted to kind of follow for my game, that fit in well with the walls that I built, and did a pretty good job at interpreting the art style for the image. And then I started generating these assets here, which I thought looked quite a bit better, and I thought would fit in better with my game. I thought the color was a little bit off, and so I tried to get it to work again. And it was getting closer to something that I liked, and so I kept working with this a little bit, and eventually started producing things like this. And I thought this style here was finally what I was going for. So then from there, I kept telling it to, follow this pattern and generate more and more assets. And then I kept getting these assets from these different images. And then I started putting them into one big image in paint.net. After getting a bunch of different images that I liked, I started to hand choose some of the ones that I wanted in my game. And then I started saving those as individual images. And I kind of started handpicking the ones that I thought would fit well into my game. So I kind of followed this like electric crystal, tombstone. I liked the obelisk that it was generating, so I grabbed some of those. I also liked some of the arches that it was making, so I was saving some of those. And then I also liked the treasure chest, so I had to build a handful of treasure chests as well. The only problem was it was hard for me to get ChatGPT to generate it to the exact scale for the tile system in my game. So as I was saving the files as individual images, I had to slightly tweak the resolution. So some of the images in my game are going to look like they have a slightly higher or lower resolution, but I thought that was fine for the playtesting version of my game. So yeah, after that, I uploaded all the obstacles into GameMaker, and so I have this long list of different obstacles here. And it looks like if I just multi-select, I have a total of 34 different obstacles in my game. I figured this was enough images for my random dungeon generation algorithm. So I'm sticking with this for now. I may add more in the future or alter these, but thought this was good enough for now. So now that I had all the images, I spent the next few days tweaking the obstacle placement algorithm in my game. This is where things started to get more exciting as I could see the map start to come together. The way my algorithm worked in the past was it would just have a list of less than 10 or so different obstacles. It would randomly find a floor tile in my map that wasn't being taken up by an obstacle and place the obstacle there. But this didn't really work well because I had a variety of big and small obstacles, and sometimes the map would generate a bunch of big obstacles or a bunch of small obstacles, and it didn't really have a good balance sometimes. So the algorithm was a little bit too random in my opinion. Another issue with the obstacle system in my game is that each obstacle is treated the exact same way, so it always blocked the player's vision if they were behind the obstacle and trying to attack an enemy behind the obstacle, and then none of the obstacles you could even walk over top of. So I wanted to add more variety to my game, so there'd be obstacles you could walk on top of, obstacles that you would block your walking path but you could still shoot around, and then have obstacles that would block your vision and your walking path, so you'd have to walk around to be able to attack the enemy. So to address these issues, I started adding different metadata properties to my obstacles. So if I go to this obstacle list here, this is just all the metadata for all the different obstacles in my game. So the first two variables here, width and height, tell the game how many grid tiles the obstacle will take up. So this is just a 1x1 grid tile that this little crystal stand thing will take up. And then I also have the sprite that the obstacle will use. And then I have this is walkable flag here. So if this is set to false, then it'll block the walking path of the player or the enemy that is walking around it. This should have dark floor, just tells the floor algorithm basically that if this is set to true, then there will be a kind of a dark floor patch beneath the obstacle. And then this is floor depth here just tells it essentially to always set it to the depth of the floor. So when the player is anywhere near it, it's always placed behind the player to make it look like as if it's on the ground. And then the last thing I have is this type here. And this type is purely used in my algorithm to tell it when it's generating obstacles for the map to place a certain amount of each type of obstacle within the map. So for example, in my algorithm now, if we jump over to that, I got a lot of commented code out here because it's still kind of being converted over from the old version of my dungeon generation algorithm to my new algorithm. So you can ignore a lot of this stuff and some of this will change. But basically what I did was I added, to address all those issues that I mentioned before of all how I wanted more obstacle types, I created this new Dungeon 1 create obstacles for type. So all this does is take in a type and how many obstacles I want to generate of the obstacle type. I call that function multiple times in a specific order. So the very first thing I do is I tell it, I want you to create 4 big arches. So it goes and looks at all of my obstacles and finds the ones that have the big arch type. So it'd be this arch, this arch, this arch. So it finds all those arches, and then it'll randomly find 4 tiles in the map and place them on the grid square. So there's a bunch of logic here to make sure it's not blocking off a walking path and it's not being placed exactly next to a wall or on other obstacles and things like that. So then this repeats over and over for all the different obstacles I want to generate in my game. So I say I want it to create 4 big ruins, 4 big obelisks, and so forth. So this is really nice because it gave me a lot more control, and I could kind of balance the amount of obstacles that were in my dungeon instead of having to be 100% completely random which obstacle it chose. So now we'll jump into the actual map again, and then I'll kind of go over each of these different obstacles. So if I go over to this tomb, this is one of the obstacles that you'll be able to walk around. And if I send some enemy waves, you'll see how the enemies interact with the wall as well. The map is a lot bigger, so it may take the enemies a lot longer to find me now. Okay, so there's some enemies. So if I come down here, you'll kind of see how I interact with the obstacles in my game. So this one, I think, okay, that one does block your vision, so you have to come in vision before you start attacking them. If I go to, like, for example, this little oasis here, this is one that is not going to be blocking your vision, so you can, you know, see everything around it. And so then I also have these terrain obstacles here, and like I said, they're the exact depth of the floor, so you always walk on top of them. But then there's also these 4 obstacles here that you can walk directly over and don't block your walking path, but there is some depth to them. So you can see if I walk over here, I stand in front of it and it's behind me. But then when I go behind it, it kind of like overlaps with my feet, if you can. And then let's go look at some of the other obstacles. Okay, so yeah, like this big arch here, this is going to block your vision and your walking path, so your player can't walk through it and block your vision when you're attacking. And then I think, oh yeah, if I go to a treasure chest, I think this blocks your walking path, but you can shoot over top of it like that. So I think that kind of covers all the different obstacle types that I added to my game. So going forward, I'm going to start working on adding a power-up system to my game, and I've actually kind of slightly started this. So I've already leveled up once, my character's level 2. So that means that I open up this, there's going to be power-ups that become available every time you level up. And now I just went to level 3, so I'll have more power-ups to select from. But yeah, this is a very early work in progress. I'll jump into this more next time, but just kind of want to give you a heads up. I'm not going to be expanding on this a lot in the next month or so. But for those of you who stuck around to the end, I appreciate it. Please like, comment, and subscribe, and I will see you in the next video.